Okay, so I'm gonna share my screen here. So a type one error, and this is as simple as I can make it. Rejecting a null hypothesis when it is actually true.
Okay.
So you get to the end and you say reject H0, but that is not the case, or it's actually true. A type 2 error, and I don't know why they use the double thing there, is failing. I don't want to say this. I see I'm still not finding the right words here. I haven't done this in a while where I've had to actually explain it. I don't like that either. Failing. So I guess I'm going to write it this way. Failing to reject the null hypothesis when it is actually false. Right. Hopefully you've seen language like this in your course.
Yes.
Okay. Now we have to you have to put it in context, because they'll sometimes throw things out like setting a guilty man free or something like that. But it really has to be done in context of your problems. Okay. So it goes back to what we were doing the other day, which is writing down the null and alternative hypothesis. So we start with that, and then we write this here. Mean price. So it comes down to, can we write H0 and HA from this? Okay. It doesn't look like you actually had to write this down. Do you want to give it a try for this?
Can we do one together and then for the next one?
Sure.
Okay.
So this one is mu, and it's written a little oddly, but we think mu is 6.99. Okay, because that was the original price, and then parents thought that the price had increased more. So this is saying that mu is greater than 6.99.
Mhm.
Okay, so here like to determine these type 1 and type 2 errors kind of generally, you have to come off to the side here, and you get your z value and you get your p value from that. Okay, and we kind of could do that here, although we need a little more information, but that's not what's important here. What's important is let's say the p value is, when you do all this, the p value is 0.03. Okay, and the alpha level is 0.05. Do you remember what to do in this case when the p value is less than the alpha?
I do not.
You reject. If the p value is less than the alpha, you reject. So the premise, like all the stuff that leads into like what you're actually doing here, is you would reject the null hypothesis. Okay, so a type 1 error occurs if you reject a null hypothesis when it is actually true. Okay, so let's say you did all this work, you found a z-score, you went to your calculator and got a p-value, and your p-value was less than alpha, and you said, okay, I'm going to reject. A type 1 error occurs when you reject the null hypothesis when it's actually true. Okay, like even though parents thought that it had increased, it really hadn't.
Okay.
So the way this is written is very difficult for me to help you with, because the typical way it's written is not like the way it is in A. So in part A, they're saying, assuming the consumer group erred here. Let me try to, okay. So this is the case where it's the claim is wrong.
Mhm.
This HA is wrong. Like they're saying, no, it's not that case. So this leads to actually a type 1 error, because it's the case where even though they think it's increased and you want to reject the null hypothesis, you want to say, no, that's wrong. It must be the second one.
Mhm.
They're actually wrong. So that's the scenario. You think the alternative is right, but it's actually not right. The original is actually true. So this part A is a type 1 error.
And that's because they think the alternative is right, but it's actually wrong, right?
Yes.
Okay.
Which isn't really the right language, but we'll go with it. If
Okay.
the second one is believed to be right, that's when you're rejecting the null hypothesis. But if it's actually wrong, that's when you're supposed to be accepting the null as being true.
Okay.
So any questions on that?
Not so far.
Okay. All right. So like it goes on to ask in part B, what could the consumers do to reduce the likelihood of repeating this error? The answer is always to reduce the alpha level. That's always the response to a type 1 error. Always.
Okay.
All right. And then it says, what is the potential consequence of the consumer group's error in part C? This is again where you have to relate it back to the language of the original problem. So the error here is that they thought that it was greater than 6.99, but it's actually not. It's actually 6.99. So
Okay.
the issue here is, it's in context. They think shipping costs are going to be more than 6.99. It's actually not. It's actually is 6.99. And as a result, maybe they don't buy something, or that there's an error in terms of like what like misinformation, I guess.
Mhm.
You're sort of creating a narrative where it's just not true. You're like, oh no, the price, pricing is going to go up. But that's going to be bad, and really it's not. Like
Okay.
think of it like egg shortages. Like what if, because we currently have an egg shortage, I guess. I don't really know, because I mean, sometimes there's eggs, sometimes there's not, right?
Yeah.
I mean, I don't know, but let's just say we thought that people are like, no, there's going to be like, you're going to pay a lot more for eggs. And then we find out like, no, it's actually not. It's going to be the same price. Like, what is the consequence of the error? Well, you might end up buying. I guess you might buy more eggs. I'm not sure. I'm really not sure how to answer this. I'm sorry. It's just so weird. The consequence is you're making a judgment that is predicated on the wrong information. Like
Okay.
you're basing your what you do based on something that isn't true, which is really, really dangerous.
Okay.
All right. So the next question really leads to the whole which is worse, a type 1 or a type 2 error. And they always go back to this analogy that you probably heard in class. This is for part D. So a type 1 error is the situation where you convict an innocent person. Did you hear that in class?
I think briefly.
Okay. And then a type 2 error is where you freeing a guilty person. Which do you think is worse? And consider yourself to be the innocent person in this scenario.
I feel like they're both not great. Um, but I I would say
Type 1 is worse.
yeah.
I mean, our whole legal system is based on innocent until proven guilty. You never want to see an innocent person be convicted of a crime they didn't commit. That
Mhm.
is in many ways way worse than um, a guilty person. Sometimes they use this in the language of diseases.
Mhm.
Like it's worse to tell a person that they have a disease that they actually don't.
Mhm.
That's really a bad scenario, if you can imagine that. And that's kind of what this is.
Okay.
Imagine someone told you you had something horrible, that would wreck your life.
Mhm.
So the type 1 errors are way worse.
Yeah.
And they sometimes use this language of you probably saw this false positive, false negative. Maybe
Yes.
heard that.
Mhm.
Okay. A type 1 is, and this is like a note card thing, is a false positive. You're falsely telling someone that they have something that they actually don't.
Okay.
That's more of the like medical side of it. Like, hey, you have I don't know, what's the worst disease imaginable? Anyway, I don't know. I'm probably getting off topic, but type 2 is a false negative, which is bad, but the false positive is worse because you think you're getting something that you don't actually have.
Yeah.
Okay, should we move to the bakery problem? The baking products company claims.
Yes.
Okay. All right. Baking products company claims that on average, their sweet rolls contain 4.5 grams of vanilla extract. Wow, that sounds like a lot. You think that's too high, and conduct a survey and determine that out of 200 samples, the mean is 3.7 grams. Even that sounds high, with a standard deviation of 0.8 grams. Assume all data are normally distributed. What is the purpose of testing hypotheses? The answer here is that you want to know whether the claim is true or not. That's kind of what we were talking about the other night. Like you think something has increased or decreased or changed. You have a way to show through these statistical tests, like whether it has or not. So when you take a standardized test and you've taken them a number of times, I'm guessing,
Mhm.
like you get a better score. So you think that you've actually improved your like score on this thing of knowledge and understanding. You can statistically prove that you actually have. And you might think, well, why would I want to do that? Um, that's what the universities do. They like let's just say you went from a 1200 to a 1220 on your test. Statistically, those might be in the same kind of groupings. Like you might have to cross over to the 1240 to show that, yeah, you've actually improved. Or in the
Mhm.
case of swimming, we were talking about yesterday, you're doing 65 seconds, but then what if the next day you do it in 67? Does that mean you're statistically slower? Not necessarily. You may find that that
Mhm.
actually is the within the reasonable range of like what you can expect. And that's the whole point of this testing, is to decide, like, you can't just do it with visual inspection. You can't just say, oh, that number's bigger, therefore it is statistically significant or
Yeah.
smaller. Okay. I don't know. So some of that is the purpose of the testing. Would you give a try here for the null and alternative hypothesis?
Yeah.
How are you doing on this one?
For the original one, I got mu is equal to 4.5.
Okay.
And then for the alternative, I got mu is greater than 4.5.
All right. So you think that it's too high though. That's where the distinction is. So I can see
Oh,
why
okay.
you think it's actually gone down like this.
Okay.
All right. Um, that's number two, I guess. I didn't realize it's the second thing they're asking for. Okay. The other things that you might want to do when you're sort of setting this up here is identify the X bar, the sigma, and the N. I mean, you're kind of doing that for the last test. Can you tell me those values for X bar, sigma, and N?
X bar is 3.7,
Okay.
N is 200, and sigma is 0.8.
Okay. Very good. So part three is asking for the test statistic, test statistic and the p-value from the table. Surprised it says table, but let's look at this. Usually you go right to your calculator for that. So the test statistic is Z. Z is X bar minus mu over sigma divided by the square root of N. So it's maybe a new formula from last exam.
Mhm.
Not really sure. You should throw the numbers in, like you should write them in here, 3.7 minus 4.5 over 0.8 divided by the square root of 200. You can also go right to the calculator though to do this, to calculate this. So do you want us to do this by hand or go to the calculator? What would you prefer here?
If we could use a calculator, please.
Yes. Okay. So do you have your calculator up? Out
Yes.
for me? Okay. So I think you're going to want to go to second vars. Sorry, trying to get to this, open this up. All right. So under stat, it's under stat test. Z test. Stat test, Z test. And notice it asks for data or stats when you click on that. Let me share that screen here. Are you seeing that now? Good. Yeah, it's up.
Yes.
Okay. So the you want to choose stats because you don't have data. It wants mu 0. That's your mu. Your mu is 4.5. Okay. And your sigma is 0.8. Your X bar is 3.7. And your N is 200. Now this next one here, not equal to, less than, or greater than, it's based on the direction of your null hypothesis. So you're going to choose that middle one. And then this time I want you to go to draw because I want you to see what this looks like because that's kind of an important thing here. Let me know if you have any questions on that before we enter it.
Not so far.
Okay, so I'm going to draw it here. So it draws a nice normal curve, which I think is really nice. Okay, so this one is like the summary here is the z value. The z value is minus 14.14. I'm writing this down. Your p value is 0, which is really low. If you don't like that, like let's say you're like, oh, I didn't really like that. You can always go back to the test and all your stuff is still in there and just go to calculate instead. But it's going to give you the same thing. It just doesn't give you the nice graph. You really only need the z and the p. So that's why I like the graph better on that one.
Okay.
Right. So we're probably gonna be doing that a bunch tonight. So just keep that in mind. That's under stat test.
Okay.
All right. So we got the p-value. The p-value is 0. And from here, we're going to go to alpha of 0.1. Do you reject? Let me snip this in. Do you support or reject the null hypothesis? So basically, it's a simple. Is your p-value less than the alpha? If it is, you reject. So your p-value is 0. Is that less than 0.1?
Yes.
Yes, reject. Now, since you reject the null hypothesis, let me know when you get up to here. I don't want to ask you a question until you're ready.
Okay.
Since you rejected the null hypothesis, is that a type 1 or a type 2 error possibility?
Rejecting the hypothesis. It's type 1.
Yes. So if you reject the null hypothesis, there is the possibility of a type 1 error. Any questions on that before we move on to new page?
No.
Which is page 2, or is the backside say comparing populations? Give me, because it doesn't, tell me where to go next, I guess.
Yeah, comparing populations is the next part.
To study long-term effects, is that one?
Mhm.
Okay. Alrighty, here we go. We've already answered question 1. It's the same answer each time, but let's look at it and then write down the, oh, sorry, it's a normalcy test. Okay. To study the long-term effects of preschool programs for poor children, researchers designed an experiment that recorded 123 children who never attended preschool from low-income families. Research randomly assigned 60 of the children to attend preschool, and the other 61 to serve as a control group who would not go to preschool. One response variable of interest was the need for social services as adults. Over a 10-year period, 38 children in the preschool group and 49 in the control group have needed social services. Okay, this is a proportion. There's out of 62 and out of 61. We care about those that have the need for social services, and 49 in the other. This is actually the type of research that is done. Although I don't know, I don't know this specifically, but this is the kind of research that is done. So does the data pass the normalcy test? That's question 2. And my question to you is like, I don't really know what you guys are using for normalcy test. Usually it's something like n times p greater than 5, maybe. Do you have any notes or anything that you can help me with that?
Let me look because I'm not entirely sure.
Okay, so it is n times p greater than 5, and then it's also n times 1 minus p greater than 5. That's what I'm seeing. But please look, see if there's anything else.
I don't see anything that really looks like that.
Okay, I'm not sure what to suggest other than this is kind of that standard one that's usually taught in these courses, NP greater than 5. So the n, and you have to do it for each group. Your n for group 1 is 62.
Mhm.
And so you take 62 and you multiply by p. P is the 38 over the 62. So you can see that that is 38 and that is greater than 5. And then you're supposed to do the same thing. You're supposed to do the 1 minus p. So it's 62 times 1 minus 38 over 62. And that will equal 24, which is also greater than 5.
Okay.
And you're supposed to do it for both. Do you have time to ask your teacher before the test, what they want you to do here?
Yeah, I think I can.
Okay, because I think it's this, but I don't want, if there's more, I don't want you to, get into an issue here. So that for the group 2, here, n is 61. So it's 61. Your p is 49 over 61, which when you multiply, it gives you 49, which is greater than 5. You do the same thing for 1 minus p, 1 minus 49 over 61, which is 12, which is also greater than 5.
Okay.
The number 3 asks for the mean difference in the population. It should be asking for the okay, that we're still not doing this order's so weird. Normally they have you write out the null and alternative hypothesis here, and the typical one is that P, the proportion from A, equals the proportion from B. Sometimes it's written this way where it says PA minus PB equals 0.
Mhm.
And what that means is that there is no difference between the populations. And that's kind of where I'm leading for the answer to number 3 here. What is the mean difference in the population? However, it could literally mean go get the proportion from A and subtract the proportion from B. It's not written well for me to tell you which it is. Like 38 over 61 minus 49 over 62.
Okay.
So I hate sort of telling you that, but that is that is where I'm a little stuck here. For part 4, it's probably asking for, and this is the formula here for 4. We will use the calculator, but it looks like kind of got to step through it. So I think part 3, when they're asking for the mean difference, I think the instructor's asking for the numerator up to this, P hat 1 or P hat A, P hat B. I think that's
Mhm.
what he's referring to here. I'm not entirely sure. For part 4 though, it's the denominator. That's the standard deviation. Now we have a little bit of work to do here to actually find P hat. P hat is something a little bit different than maybe what you're thinking. P hat is you take X A or X1 plus X2 or XB over
Mhm.
NA plus NB. Basically, you take the tops. It's like the one time you can violate the whole how to add fractions.
Mhm.
But this is what it becomes, and it's some sort of a decimal here. So let's actually calculate that. Okay. All right. So I get 0.7073. It also actually reduces nicely to 29 over 41. Okay. So we're gonna use the formula in the denominator, and let me just snip that part in. I don't think the calculator will just calculate the bottom. That's why we're doing this. It's going to calculate the whole thing. So this is the square root of 0.7073, 1 minus 0.7073, 1 over 61 plus 1 over 62. Do you want to try calculating that for us, please?
Yes. Yeah. I got 0.082.
Yes. Okay, so I think for the next part, we're going to go to the calculator here. Let me just confirm that, getting the, no, well, kind of. So they want you to do a 90% confidence interval. So we're going to go back to the calculator. So you know where to go with this. Let me look before I tell you. So I believe it's under stat again. Stat test 2 prop z test. Okay, so to find this here, it's stat test 2 prop or 2 proportion z test. So let me go to the calculator there. So much easier in the calculator. All right, so if you get there, you hit enter. Notice it wants x1, n1, x2, n2. And so that's the proportions we were using. 38 over 61, so 38, 61, and then 49 and 62. And then what to choose here is based on the alternative, which we never wrote. I'm going to go back and look at the, oh, so, okay, so you're not even doing, I'm sorry, you're not doing this. You're not doing this. Sorry, it's stat test. You're doing a 2 prop z interval. You're doing this one here, C or B, 2 prop z interval. Sorry about that. You'll notice you have basically the same numbers there. Let me update the document here.
Okay.
And you want a 90% confidence interval, so you change the C level to 0.9, and then you calculate. So you want the first numbers there, the first line basically. Your instructor says you must include the inequality. So what I take that to mean is you got the two numbers minus 0.3002 minus 0.0345. So it's less than, I actually don't know if it's less than or equal to or just a less than. I don't know why it would matter. But this is PA minus PB. This comes from the null hypothesis. Let me see if I can find out here if it's so in every other class I've seen, it's never written as an inequality. It's always written in interval notation. Although it doesn't include the endpoint. So I guess I would probably go right there. I would change it to just a less than and a less than.
Okay.
But really we got kind of away from the main point, which is you've got to know how to do this. You've got to know how to go to the right place to push the buttons for this.
Okay.
All right. Now, when you're looking at this interval, the only thing you care about is whether 0 is included. 0 included or 0 not included. All right. So if 0 is not included, you reject the null hypothesis. When you look at this interval, is 0 included in here?
No.
No. So since it's not included, you would reject the null hypothesis. If 0 is included, you fail to reject. So when you see number 6 on your page there where it says interpret, you learned by now in math class that it means to write a sentence here. You want to use the words reject or fail to reject. So in this case, we would reject reject, but we don't even know what it is. There is no null hypothesis. So let's just use the interval. So we're going back to the numbers here, and we are, and you use the confidence intervals. So you say we are 90% confident that the true proportion difference is between, and then you use those numbers that are given, minus 0.3002 to minus 0.0345. I think they typically don't want you to add in like some context. They want you to say the difference between the preschoolers and the non-preschoolers. You know, basically your control group or not.
Okay.
I'm sorry, this is just not, I mean, this is not how it's typically presented in the college classrooms. So you're getting a okay. So the main takeaway from side 1 and side 2, I guess, is one was a z-test because they gave you a population mean. The other one was a z-test for proportions, kind of like what we were doing last time. You got to know whether it's a proportion or a mean on that. We also talked about some type 1 and type 2 errors. All right, so where should we go from here?
If we could go to the next practice test, which is
Tell me what's at the top of it. That way I can. Is it the?
It's the one about the
trampoline.
Trampoline, yeah.
Okay. So you think it's going to be just like this, just like, you know, front and back kind of thing, where?
Yeah, he said it was going to be 3 questions, and it's like the first one's a type 1 or type 2. Like it's exactly like this.
Okay. Trampoline park claims that out of every 10,000 kids that attend, only 35 of them will sustain a significant injury. OSHA is asked to investigate the claim. They send a team who does some sampling to the park's records, reject the park's safety claim. Okay. Okay. I mean, like it's this, normally you write a null and alternative hypothesis. The key thing here is that they reject the park's safety claim. So they're basically rejecting the null hypothesis. So which type of error is that? Possibly.
Type 1.
It's a type 1. The type 1 is when you reject the null hypothesis when it's actually true. Okay, and so they're saying here that we're going to reject the null hypothesis. They're saying we don't believe that 35 out of 10,000 is the right number, but it actually is true. It actually is true. That's like the language you want to hear over and over. Reject the null hypothesis when it's actually true. You say something is not, you reject it, but it really is true.
Okay.
So the part A here is the what kind of error did they make? And you just want to say type 1 or type 2. And you want to follow it up with rejecting the null hypothesis when it is actually true. You don't have to give anything in context here. You just want to repeat the words that I typed at the top of this document.
Okay.
So that's this. If it's a type 2, it's failing to reject the null hypothesis when it's actually false. You'd want to say that as well. Sorry, that's part A. The only way to reduce this error is to lower the alpha level, to reduce the error of a type 1. To reduce a type 1 is to lower the alpha level. So you've seen a couple problems like alpha's 0.1, you can make it 0.05, or you can make it 0.01. Lowering the alpha level is the only way to. So we can actually answer part C, I think, reasonably well in this problem, which is the consequence here is there. I think the claim here is that there's more likely to be an injury, is probably the claim. And they're saying like, yeah, there's more likely, there's more than 35 out of 10,000 people that are going to get injured, but it's actually false. So they're saying like there's a problem when there isn't a problem. And that's what you want to convey here. You want to convey like, okay, there's a problem, but it's not actually a problem.
Okay.
And it is always the case for D. It's always that type 1 is worse. Always. Okay, so we do have to stop here. I need a short break. So I'll see you back here in 10. Just make sure you use that